Hey everybody, I'm Chili. Welcome back to Beginner C++ Tutorial 23. Today we're doing another game project. It's going to be Minesweeper. So this is going to be a nice game. It's going to tie together that stuff we learned about 2D arrays, enumerations, and switches. And it's going to set up the final topic that we're going to be looking at in Beginner. I'm going to keep this one short and simple. We're not going to do a lot of polish on it. You've seen me doing that stuff before. You don't need to see me doing it again. Now Minesweeper was the original preloaded Windows game all the way back to Windows 3.1, basically on all Windows. Probably Windows 10 has it, I'm not sure. But anyways, I know Windows 7 has it, but you guys might not be familiar, so let me give you a basic rundown how it works. So you got this grid here, and you click on squares, and it reveals them. And some squares have numbers on them. What does that mean? Well, that means how many bombs are adjacent to that square, and you don't want to click on the bombs. So what you do is you use a little bit of reasoning. You say, okay, so this square has only one bomb adjacent. There's only one unknown square, so that must be a bomb. So you put a flag there. You right click, you give it a flag. And you say this one has one. That means that if it's here, this one must have nothing, and you can free that. You can free that. Oh, here we go. This one's on the corner, bomb there. Free it up, free it up. If you try to click on the ones that you flagged, you can't do it because, I mean, why would you want to do that? You want to commit suicide? Are you retarded? So you proceed to flag squares and you make your way through the grid. The object is to flag all the squares and reveal all the squares that don't have bombs. Flag all the bomb squares, reveal all the others, and then you win. If you click on a square with a bomb, like here, then shit blows off and you're dead. All in all, a pretty simple premise. Let's get on with it. Now, of course, first off, you're going to want to clone the repo, right? Let me show you some little tech here. So you can clone a repo as usual. Like, let me just go to Yumtard's repo here, Spaceballs. Shit. Okay, Spaceballs. There we go. You can clone directly from his repo. Or what you can do is you can click on this button here, fork, and that will basically clone his GitHub repo onto yours. And now you can clone from this one, and because it's on your GitHub, you can now directly push to this repo. You can push all your changes and shit. Whereas if you clone directly from his and you tried to sync, you wouldn't be able to push. You would have to create another repo on yours, then change your local repo to point to your remote, and then you could push. That pain in the ass. So what I recommend you guys do is you go to my repo, you go into the wiki page on the link, and you fork my repo to your GitHub. And when you clone that shit, you should get code like this if you look at the history of commits. And let's just take a look at it here. It's basically the framework, but I've added the rectangle, I've added vec2, and I've added drawRect function. But here's the thing. I've changed vec2 and rectangle because before they were integers. No, they were floats, but I've changed them to use integers because we're going to be working on a gridded game here. It doesn't make sense to use floats. Let's use integers for everything. So rect I is going to be integer rect, again, left, right, top, bottom, all the normal stuff. And same with vec2, I changed it to va2 for integer, but it's dumb, but it doesn't matter. And that's basically everything. I removed the function to normalize because that doesn't make any goddamn sense with an integer vector. And I've added operators for division, but that's the only real change that we've got here. And the graphics, again, we've got the drawRect, 2 versions of it. It's all good to go. The other thing I've added is I've added the sprite codex, and that's going to give us all of our functions to draw our tiles here for the game, and it also gives us a couple of constants here, the size of the tiles we can reference, and base color. I'll get to that later. Now, before we actually dive into the code, let's take a quick minute here and just do a little design work here. So we're going to create a class that's going to represent the minefield, and that class is going to contain an array, which we're going to logically think of as a 2D grid, right? So here's going to be, I don't know what we'll call it. We'll call this the field. And it's going to be an array of type. Every one of these elements in the array is going to be of type tile. All right. But tile is going to be a part of the minefield. The outside world, the game, there's game, is going to interface with minefield. It's not going to know about tiles. It's just going to know about how to work with the minefield. And minefield itself is going to manage the tiles in the array here. So the minefield is going to have an array of tiles, and every tile is going to have two main pieces of information. One is a Boolean, which tells whether that tile contains a bomb or not. And the other one is going to be a state, and that is going to be an enumeration type. And there's three states that tile can have. It can be hidden, it can be flagged, or it can be revealed. So these are the two pieces of information that represent, the state of a tile, basically. And minefield is going to have a whole shit ton of those tiles organized in a 2D grid fashion. All right, so we're going to create a new class. We're going to create a new file, minefield.h, and the class is going to be minefield. Now, minefield is going to contain within it a definition for the tile class. And the tile class is going to contain inside of it a definition for the enumeration, the state enumeration of the tile. Now let's give it some private member variables for the state and for the bomb content of the tile. And we'll give those member variables just some default values here. Now our minefield is going to have dimensions in tiles and the width and the height in tiles. So let's give it some static const expression for that. And now we got to create our array that is going to hold the grid of tiles. And the size of the array is going to be the width times the height. Now what I want to do is I want to create a constructor for the minefield. And it's going to take, what is it, minefield? God damn it. Here we go. Int n mine. So it's going to take the number of mines that we want to spawn on our minefield. So first things first, we're going to need a function on minefield. And that one's going to be for spawning mines. And I just realized I'm making a huge mistake here. This is not a minefield. What was I thinking? This is obviously going to be a meme field. So let's rename that. And obviously we have to rename this file as well. So we'll rename that to a meme field. And this is not going to be has bomb. This is obviously going to be has meme. And there we go. We'll put meme field in here. And here we want spawn meme. There we go. Okay. Now, so we're going to spawn a meme, a function for spawning a meme. We also want a function bool has meme const. So this will let us check to see if a tile contains a meme or not. And that's about it, I believe, for right now. So we create those definitions here in memefield.cpp. Now what I want to do is I want to do sanity checks because I like them. So assert.h. And I know some of you guys, you've been skipping these sanity checks, and I've seen you guys then come in the forums and stuff and ask questions, why doesn't this work? And I noticed that if you would have put the sanity check in there, you would have found your own mistake quickly. So I'm just saying, these things, they're not useless. They do help you out to find your own fuck-ups. But of course, you're not going to make any fuck-ups. So you never need this stuff, right? Har, har, har. So here's a sanity check to make sure you're not trying to spawn a meme on a tile that already has a meme. So we assert not meme, not has meme, and then we say has meme equal to true. There we go. And has meme, the function, will return has meme. Now, here's where things get a little more interesting. The meme field, we've got to spawn a number of memes in mines. This is not kosher. It's n memes. Can't get that mixed up. That's like worse than a syntax error. N memes. There we go. So I want to do a little bit of a sanity check here. Obviously we want to have more than 0 memes. So n memes, we want to assert n memes is greater than 0. And we can't have more memes than there are squares. We can't have a thing filled with memes. There has to be at least one free square. Otherwise, it's kind of unfair. Just a little bit unfair to the player. So what we're going to do is we're going to assert that n memes is less than width times height. So this sanity check here is going to... Wait. There we go. This is going to make sure that the n memes is a kind of a semi-reasonable value at least. Now, what we want to do is we want to continually try to spawn memes until number of memes have been spawned, but we're going to do it randomly. We're going to put them on random places. So what we want is we want random, first of all. Random. And let's see, what are we going to do? Well, let's set up a random device and let's spawn our Mersenne Twister random number generator here. And let's also set up a couple of random number distributions here. The X one is going to be from 0 to width -1, and Y is from 0 to height -1. So these are the ranges of the coordinates in grid space that we want to be able to have for our random number generator to generate bombs. Now we're just going to do a loop where we keep trying to generate bombs in squares until we have generated n memes. Oh, fuck. Not bombs, memes. Big difference. So we'll create a loop here, n spawned equal to 0 as long as n spawned is less than n memes, n spawned plus plus. And then what we're going to do, we're going to include vei2 because we're going to need it for our coordinates here. So vei2, there we go. And we're going to create a local vei2 here for the spawn position. We're going to set that spawn position equal to a randomly generated position. And then we're going to check to see if there is already a bomb at that position. We're going to keep doing this until there is not a bomb, and then we're going to set us up the bomb. But, so, I have to check that position in the grid, so I have to do my, my grid space to 1D array space mapping. And what I want to do for that is I want to create a separate function that's going to do that for me. It's going to make the code a lot nicer. It's going to be good times. So, we want a function, and I'm going to make it a private function. So what we're going to do here is we're going to, in meme field, we're going to create a new private section. I'm going to create a private member function that will allow us to map from the 2D grid coordinates and will get us a reference to a tile in our grid. And if we create the definition for that, promote it, now all we got to do, I don't know why this is red, but who the fuck cares, man? IntelliSense flipping its shit out, what else is new? So, we're going to go return field, and what's going to go in here? Well, it's going to be grid position dot y times width plus grid position dot x, and this is going to return a reference to a tile in our field. So now in here, we can do something like this. We can go, okay, while tile at spawn position dot has meme. So continually regenerate a spawn position until we find a place where there is no meme. And once we found that place, we can go tile at spawn position dot spawn meme. And there you go. Everyone is happy. Except for fucking IntelliSense, you can suck my dick. But anyways, I don't know why. Maybe it's because meme field like this. There we go. Okay, so basically it just means that my fucking quick whatever you call it just fucked up. That's okay. All right, so that's actually good to know. If you have an inner class like tile, you've got to put this in there yourself because the visual, the quick actions ain't gonna do it for you. And just the more you know, right? Anyways, let's continue on. So now we are generating our random field of memes, and we want to be able to draw. We want to be able to draw this bullshit now. So what are we going to do? Well, we'll add a function to draw. Looking like this, but we need to know about graphics, so let's jam some graphics in here. And if we do that, that'll fix this guy up here. Let's do our quick actions. Try not to fuck it up this time, Visual Studio. Thank you very much. And what else? Okay, so we want to loop through our X's, we want to loop through our Y's, and we want to do our thing. So I'm going to do this loop here a little different, as you can notice. Instead of having int y and int x and looping through them, I'm going to have one vei2 grid position 0 0, and in the outer loop I'm going to loop through grid position.y, and in the inner loop I'm going to loop through grid position.x, and then I can use that grid position directly to pass it to tile at, and I'm going to do tile at blah dot, draw, but we don't have a draw function yet. So we're going to make in tile, we're going to make a draw function. So we'll do void draw const. Now here's the thing about draw. It's going to need information to draw. It's going to need graphics. So graphics. Now let's start. Yeah, graphics GFX. But it's also going to need a position to draw on the screen. It's going to need to know the pixel coordinates on the screen. And we're going to also use va2 to represent pixel coordinates. It's a little confusing. The same data type is going to be used to represent two different concepts. One of the concepts that's going to represent is coordinates in grid space. For example, when we call tile at, this va2 represents a coordinate in grid space. But when we call tile.draw, we're going to pass in a va2, const va2 ampersand screen position. So it's going to represent a position on screen in pixels. So it's just something that don't get them mixed up. This here means a screen position in pixels. This one means a grid position in, tiles or whatever you want to call it. So create this function. Let's fucking define the fucker. And what we're going to do here, this is going to draw a tile depending on a whole bunch of different shit. Basically, depending on this information in the tile. So whether it's going to draw a tile, whether it's based on whether it's hidden, revealed, whether it has a meme or doesn't have a meme. So how are we going to do this shit? Well, first off, let's switch on the state of the tile. All right, so here are the three states of that the tile can have. Now, if it's hidden, we just want to draw basically the button looking thing. So first things first, we got to go into include. We got to go sprite. Fuck, God damn it. Yes, sprite codex. There we go. And so now we go sprite codex and draw tile, not tile 0, draw tile button. So when it's hidden, it just looks like a button that you can press. And we're going to pass in the screen position, and we're going to pass in the graphics. And that'll draw the tile button. Now, flagged is a little different, because flagged means it's not revealed, it's still hidden, but it also has a flag drawn over top. So you got to draw both. So first we draw the base tile button, and then we go sprite codex, draw tile flag, and again, screen position and graphics. Now in the final state here, the revealed, there can be two cases. One is where it has a bomb, and one where it doesn't have a bomb. So if it doesn't have a bomb, and by bomb, of course, I mean meme, pardon my French. So if it doesn't have a meme, then we want to draw just an empty tile. So we'll go sprite codex, draw tile 0, that's for an empty tile. Now if it does have a meme, and then we draw tile bomb, because I forgot to rename this here. You can rename it yourself if you like, but I'm going to leave it as bomb for now. So this is going to give us our basics for our drawing of our tiles. So now we do tile at grid position dot draw. And here's a problem. We need the screen position, but we only have the grid position. So we've got to convert a grid position to a screen position. I just realized something incredibly fucking annoying, and that is that this grid that I used for tutorial 21, it's fucking backwards. This here is Y, this is X, right? Because look here, as we increase X, this one is going up. We increase Y, this one's going up. The fucking X's and the Y's are swapped. Oh my god, I now have to fucking make a note on tutorial 21 or something. Piss, my balls, bite my balls. Anyway, so what we want to do is you want to go from a coordinate in grid space, like let's say, 0, 1, and we want to map that to a coordinate in screen space, in pixels. So let's say that our grid, the top left-hand corner of our grid is at 0, 0, the top left-hand corner of our screen. So how do we find some of these positions here? Well, I mean, let's say this is 0, 0, right? So what's this position here? What's going to be the top left-hand corner of this tile? Well, it's going to be 0, 0 plus the width of a tile in the X. So let's say the width of a tile is 16 pixels. So this is 0, 0. This is going to be 16, 0 in screen space. This one here is going to be 32, 0. And it's the same deal down here, right? If this tiles are 16 pixels high, then this one here is going to be 0, 16. Of course, these X's and Y's are fucking backwards. Sure, it fucking pisses me off. Anyways, so all we got to do is multiply the X coordinate by the width and the Y coordinate by the height, which both happen to be the same if the tiles are square. So what we can do is we can go grid position times and sprite codex, not base color. Where's the other one? Tile size. So we multiply the tile size by this vector. It'll multiply the X and the Y by that, and that'll give us our position in pixels in screen space. And we need to pass in our graphics, and there we go. Not grid position. Thank you, grid position. All right, now we're almost there, but look at this one. Fucking compiler does not like it. Object has type qualifiers that are not compatible with the member function. So this function is a const function, but tile at isn't const. It returns a reference to a tile. If we try to make it const, it's not going to work because you can't return a reference to a member. If the function is const, you can't return a non-const reference because that would allow you to change this shit. You would be circumventing the constness of this function. And what you can do is you can create another version of this function, const tile reference tile at. And let me just copy and paste this shit here. Save us some time. And so I can create a version of this function. It's identical, has the same signature, except this one is constant and returns a const reference. And that will allow the compiler to choose one of these versions of the functions depending on the situation. So let's create the definition in here. And all we got to do in here is, well, first off, we got to fucking do meme field tile again because Visual Studio's being a little bitch. And then here, all we got to do is return this. All right, so copy and paste that, and now we've got two versions of tile at. One can be called in a constant context. The other one can be called in non-const context. And this will allow us to use our tile at anywhere we goddamn please, like for example here. All right, I think it's about time to test our meme field out. First, let's try to build it and make sure there's no errors, because you never know. All right, there we go. Now let's incorporate the meme field into game. So in game.cpp, we're going to include meme field, and then we're going to create a meme field user variable, meme field. We'll call that the field, and we'll toggle this one here. Now the field has to be generated, so we're going to pass in a value for the number of mines, and it doesn't really matter at this point. Let's say 20 mines. So we're going to generate 20 mines in our meme field. Memes. I said memes. Now we want to draw those fuckers. So we're going to go field.draw graphics. And this should draw our shit. Build solution. Run. All right. This is not exactly what I expected. First of all, we should have more going down. Looks like we got about 20 across, but we don't got 16 down. And that's obviously not going to be, it's not going to be kosher. We want 3 doors down. We want more than 3 doors down. How do we get this shit? First of all, where's my freaking meme field? There it is. All right, so draw. Okay, so we got width, we got height, width times height. That's good. Let's toggle. And let's go down to here. As long as grid position.x, okay, that's fine. Grid position.y is less than height. Grid position.y plus plus. All right, let's set a breakpoint here inside the loop and see what's happening. So we start our loop, get here, grid position.x and y both equal to 0. So if I press continue, it's going to run through one iteration of the loop. Now we got x equal to 20, y equal to 1. And right away, I see the problem here. And the problem is that we run through this x loop once, then we exit, we go through the y, we increment y by 1, we enter the x loop. But the problem is grid position.x is still at 20. But we're starting a whole new X loop here. We want it to reset back to 0. If it's still at 20, it's going to check this condition. It's immediately going to exit. So it's only going to draw the first line, and then X is going to be stuck at 20. So what we want to do is in here, we want to go grid position.x is equal to 0. It's slightly redundant. The first time through, it's going to set X equal to 0 in here, and it's going to set X equal to 0 again in here. But it's a simple solution. It'll get the job done. Now, if we build that, we run it, we get our grid. It's looking a little weird. The background is black. If you're familiar with classic Minesweeper, it doesn't look like this normally. So the problem is that to save put pixel calls in the sprite codex, what I did was I set it so that the background is assumed to be 192, 192, 192. So it doesn't have to set those in the put pixel. So you've got to fill that background with 192, 192, 192. So what we want to do is we want to draw a rectangle behind the grid. So before we draw the grid, we draw a rectangle of gray, and that will cover the background color. To draw a rectangle, we're going to need a rectangle. So I'm going to create a function in here, and I'm going to make it public, and I'm going to call it getRectMate. So we do our getRect, and then in here, we're just going to return a rectangle. We're assuming, for the time being, we're assuming that our grid is going to be positioned in the top left-hand corner of the screen. So the top left, what are our options for left, right, top, bottom? So left is 0, right is going to be width, top is going to be 0, bottom is going to be height. So we return a new recti with these dimensions, and we save that. So now we got our getRect function. Now what I want to do is I want to go into draw, and I want to draw a rectangle behind our thing. So we're going to go graphics.drawRect and getRectMate. No, stop that. GetRect, and I'm going to do sprite codex and base color. So we'll draw a rectangle, the base color, then we're going to draw all of our tiles. All right, might have had a slight miscalculation here. Let's go back to getRect, and let's multiply width and height by the size of a tile. All right, that's looking a little better. And now this looks like a big grid of covered up tiles that you can click on, perhaps. But you can't click on shit right now. It's not done yet. But this is kind of boring. I want to test out. I want to be able to see at least whether or not I can see any bombs. So let's add a test. Well, first off, let's commit this. We got so far so good. So we got our meme field, basic hidden tiles all done up. Now let's go into the constructor and let's just add some test code in here. We want to reveal just a bunch of random tiles here. So I'm just going to call tile. I'm going to go through a loop. I is equal to 0 to 120. And we're going to generate random X and Y and try to reveal that tile. So we need some functions in our tiles for revelations. So let's toggle header code file here. Let's go into here. So void reveal. And let's do bool is revealed constant. There we go. All right, so let's do the thing. Yes, create the definition. Great. So reveal tile. First off, let's do a sanity check. Let's assert that the state is hidden. You can't reveal a tile that's already been revealed. You can't reveal a flag tile. And then we're going to go state is equal to state revealed. And that's as simple as that. Is revealed is going to return state equal to state revealed. There we go. That'll let us test if it's already been revealed. All right, now we'll go back to our good old friend. Where is it? Test here. So we can't just reveal at random because we might trigger our assertion there. So we'll go if. Let's create a v2 grid position is equal to this. So we'll randomly generate our shit, home, make that const. And then if tile at grid position dot is revealed not. So if it's not revealed, then reveal it. Seems fairly good to me. Let's make sure that we're using the same grid position we used for the test. Probably a good idea. And now this should reveal a bunch of tiles at random when we construct this fucker. And now we can see we've got our hidden tiles, we've got our revealed tiles, and we got revealed tiles with memes in them. It's only one meme because, like I said, I'm keeping it simple for this one. I don't want to waste a whole shit ton of time. All right. So far, so good. All right. Now what I want to be able to do is I want to be able to get the mouse input working for our motherfucking meme game, whatever. So the problem is we click on a screen, we get mouse information, and that information is in a screen position format. We click somewhere, we get a position, let's say it's right here. And so we want now to convert that into grid coordinates. So this is going to be grid coordinate 2, 1. So let's say the user clicks on screen coordinate 42, 29, and you want to be able to map that to a coordinate on the grid. We're looking at the grid, we can see that the coordinate is going to be x2, y1. It's going to be this thing switched around. But how do we do that in code? How do we calculate it? Well, to get the coordinate of the top left-hand corner, given the grid coordinates, the top left-hand corner in screen space, given the grid coordinates, we multiplied by the width and the height. So the grid coordinates times the width and the height. That's to go from grid to screen. You multiply the x by the width and the y by the height. So to go from screen to grid, what do you think you're going to do? Opposite mapping, you're going to divide. So if you want to find out where on the grid this is, divide by the width of a cell or a tile and the height of a tile. So divide both of these by 16, and what you're going to get when you round down, because integer division rounds down, is you're going to get 2 and 1, which is the thing we want. So all you got to do is motherfucking divide by the size of the tiles here to get the coordinates in grid space if you have the coordinates in screen space. So what we're going to do... Alright, so let's add some functions to handle mouse clicks for revealing. One function anyways. So we're going to do void on reveal click, and we want to get a constant v2 screen position for that click. And what we're going to do here is I'm going to create definition. Now, to do this, to handle this click, we're going to have to convert this screen position into a grid position. So let's also create a private function, and we're going to go, what should we do? We'll go v2 screen to grid, constant v2 ampersand screen position. All right. So this little guy here is going to do our conversions for us. And we're just going to return v2. How is this going to be? It's going to be division, right? So we're going to return screen position divided by sprite codex. Where's my thing? Here it is, tile size. So that's why I added this dividing function here. Makes life easier. So we can just divide by this integer, and that'll divide both the x and the y by tile size, return the result, which should be the grid position. Then let's just promote that. Where's our new function that I just added? All right, here it is. On reveal click, let's convert first of all. We'll go const v2 grid position is equal to screen to grid screen position. So this will convert our screen position that we got passed into a grid position. Let's do a quick sanity check. So we'll make sure our grid coordinate is actually within our grid, and then we will attempt to do the reveal click. So we use tile at to get a reference to the tile, and then we check to see if it's revealed, and if it's not revealed, we reveal it. Fairly simple. Then in game.cpp, we're going to check to see if the left mouse button is being pressed, and if so, then we're going to send that message to the field. So if window.mouse.left is pressed, field.onReveal click, window.mouse.get position. Now get position returns something called a pair, but I want it to return an integer. So we're actually going to go into mouse. We're going to go into mouse.h, and we're going to add another class in here. So we've got get position x. So let's change get position because we're not using pair. We've got something better than pair. So let's go into here. Let's go include. So # include v2. And where's get, here it is. Let's return, instead of returning this pair, we're going to return v2. And this should all just be able to stay the same. So now mouse is going to return the kind of thing that we want it to return. Let's go back to game if I can fucking get there. We go. So now we just do get position dot get position. And there we go. So on reveal click window dot mouse dot get. What is your goddamn problem? No user defined conversion from pair to v2 exists. You fucking bastard. I changed that function. You'll get over it. You'll figure it out. Let me just make sure I'm not doing anything wrong here. Get position. This was inside of event. That's something else. We'll be talking about event very soon. But inside of mouse, there's also a get position. Here it is. So we got to replace this with v2 as well. And this is only the declaration. So I got to go to the definition in here, and we got to replace this with v2. And this should work fine. Let's go back to game.cpp. Yes, you are happy now. So now we should be able to reveal shit when we click on it. Build solution. Yes, let's try it. Nice. It's working. If I hold the button down, we can reveal a whole bunch of shit.